Good morning. Today, I can determine if events are independent using P of A and B equals P of A times P of B, or P of A equals P of A given that B. So, to determine if events are independent, I can use either of these formulas. Depending on what information they give you, you might be able to use both, or you might have to use one specifically. And basically, you need to memorize these two formulas. To help you memorize these formulas and one more, we have a song. So I'm going to get that song up for you. All right, so these are the formulas that you need to know in this unit. The first two we're going to be talking about in the next lesson, the formula for or and the formula for and. The two bottom ones are what we're going to be talking about today, and these are the two different formulas to determine independence. So there's P of A and B equals P of A times P of B, and then P of A equals P of A given B. So to help us remember all this, we have a song, Schlansky.com, YouTube, playlists, Common Core Algebra 2 songs, and probability. P of A or B equals P of A plus P of B minus P of A and B. P of A and B equals P of A plus P of B minus P of A or B. P of A and B equals P of A times P of B. Yeah, P of A equals P of A slash B independency. Yeah. So, again, these are the formulas that you need to know for this unit. The two top ones we're going to talk about in the next lesson. And for independence, we have P of A and B equals P of A times P of B, yeah. And P of A equals P of A slash B for independency. Now, which one should we use? When you have a choice, I like to use this one, and I'll show you why, but I'll show you both methods. So in order to do this lesson 2, we need to know how to use two-way tables. Well, we've done that in the previous two lessons. And whenever I have a two-way table, I always want to total everything up. So I'm going to total everything up. 54 plus 36 is 90. That's 65. That's 45. Total up the rows. That is 106. That is 94. And that is 200. For this group of students, do these data suggest that gender and preferred music styles are independent? To determine if events are independent, again, we have two different methods. I like using P of A and B equals P of A times P of B, yeah. And I'll show you why. So, first off, we need to know what A and B are. It doesn't exactly matter. One of them has to be a gender, and the other has to be a preferred music style. So I'm going to say that A is going to be female. So the only thing that B can't be is male. One of them has to be one of these. The other one has to be one of these. So I'm going to go rap. So P of A and B. So first of all, there's no condition in either of these, which makes the total the denominator for each one. That's the main reason why I like using this formula, because there's no condition, and I feel like conditional probabilities are a little bit trickier. The denominator is going to always be the total. So I've got female and I've got rat. It might be helpful to circle them. What's P of A and B? The probability of female and rat is 25. P of A, probability of female, is 106 over 200. P of B, probability of rat, is 65 over 200. So now we just need to see if this holds true. So we're going to go to our calculator. We're going to type in the left-hand side, and we're going to type in the right-hand side. So my left-hand side is 25 over 200. Alpha y equals enter, 25 over 200. This will basically let the calculator do the reducing for you, 1 over 8. And now I'm going to type in alpha y equals enter, 106 over 200 times alpha y equals enter. Oops. Alpha y equals enter, 65 over 200. 689 over 4,000. So these are not the same. So this would prove that they were independent if this held true. Since it does not hold true, they are not independent. If they are equal, they're independent. This is the test for independence. If it holds true, if it doesn't, then it's not. Now, the other way you could do it, P of A equals P of A slash B. So, P of A, probability of female, is 106 over 200. Probability of A given B. So with conditional probability, the condition comes after the given that, after the slash. So the condition is wrap. So I'm looking in this blue. Out of the 65 people who like wrap, 25 are female. Are these equal? Well, alpha y equals enter, 106 over 200, 53 over 100. 25 over 65, 5 over 13. Those are not equal, therefore not independent. And listen, whatever you get for this one, you're going to get the same thing. Either it's going to be yes or it's going to be no. Doesn't matter which one you use. Let's look at the same answer in the end. Did something get erased here? I don't know what's going on. Yeah, it looks like something got erased over on this side, but either way, so you have two options. I prefer the one on the left because there's no condition in any of them, so I think they're a little bit easier to come up with. The denominator is going to always be your total. A and B is from the inside. A and B are from the outside. Pop each side into the calculator to see if they're equal. Or you could use this one, which again, some of you might prefer this one because it's 2 probabilities instead of 3. But for those of you who get a little confused with the condition, you might be better off using the one on the left. And that's it. Number 2, why don't you start by totaling everything up? I'll give you a few, 15, 20 seconds to total everything up. Whenever you have a two-way table, we need to start by totaling everything up. 50, 75, 25, 100. And don't forget your total, very important for this. Does the data suggest that the gender and type of payment are independent? P of A and B equals P of A times P of B. Yeah, that's my go-to. It doesn't specify which ones to use. It just says gender and type of payment. So I'm going to choose a gender. I'll go male this time, instead went female last time. And I'm going to choose a payment type. Let's do cash. It doesn't matter. If you chose female in credit card, you'll have different numbers, but we'll have the same answer at the end of the question. So, P of A and B. I've got male. I've got cash. Probability of male in cash is 10 over 125. Remember, there's no condition, so your denominator is going to always be your total. Probability of A, probability of male is 50. Probability of cash is 25, and kind of circling it kind of helps you see what's going on. So now I'm going to type in the left-hand side. 10 over 125 is 2 over 25. Alpha y equals enter, 50 over 125 times alpha y equals enter, 25 over 125, 2 over 25. They're equal. That means they're independent. Now let's do it using the other formula. P of A equals P of A slash B. P of A, probability of male, is 50 over 125. P of A given B. Well, B is the condition, so I'm going to circle the condition. Out of those 25 people who use cash, 10 are male. I'm going to go to my calculator. I'm going to type in the left-hand side. Oops, alpha y equals enter. 50 over 125 is 2 over 5. 10 over 25 is 2 over 5. They're the same, so they're independent. All you're doing is determining if the left-hand side equals the right-hand side. Once you set them up, just kind of pop them into your calculator. If they're the same, they're independent. If they're not the same, then they're not independent. That's really all there is to this. There's going to be some little twists later on, but for the most part, it's just if you know how to do it, you get it right. I want you to try number 3 on your own, so please pause, try number 3 on your own, and then unpause. Okay, now that you tried number 3 on your own, I'm going to total everything up. 60, 40, 19, 81, 100. You want to know if they're independent. P of A and B equals P of A times P of B. Yeah, let's choose what we want A and B to represent. Gender and opinion. Let's go back to female. And let's go in favor. So if you chose different variables, then your numbers are going to be different, but you're going to get the same final answer as me. This formula, I like this formula because the denominator is going to always be my total, so I don't have to think about that. P of A and B, female and in favor. 4 are female and in favor. P of A, 40 are female. P of B, 19 are in favor. Alpha y equals enter. 4 over 100. My right-hand side, 40 over 100 times alpha y equals enter. 19 over 100. 19 over 250, so I've got 1 over 25 I've got 19 over 250. Those are not the same. So it is not independent. I will do it. Listen, you don't have to do it with both formulas. I'm just going to do it with both formulas just so you can see how it would work with both formulas. P of A equals P of A slash B for independency. Probability of female. There are 40 females out of 100. The second one is conditional. P of A given B. So given that we're in favor, I'm only looking in there. Out of the 19 people that are in favor, 4 are female. Alpha y equals enter, 40 over 100. Alpha y equals enter, 4 over 19. 2 over 5, 4 over 19. They're not the same. So like show that they're not the same. Don't write they're equal. Put a slash through it or put an X. Not independent. All right. So most of this is pretty much the same. So let's jump to number 7 now. There is no 2A table. So you might need to make a 2A table, or they might give us the information that we need within the problem. So let's see if they give me the information that I need. If so, I'll just sub into the formula. Otherwise, I'll create a 2A table to find what I need. A study was done at West Apple High School analyzing the student lateness and Regents exam results. It is found that 32% of the students arrive to school late and 72% pass their Regents exams. So that looks like P of A and P of B there. Arriving to school late, Regents exam. 14% of the students who do not arrive late do not pass their Regents exams. So that is not P of A and B. So what I'm thinking at this point is to create a 2A table to get a little bit more organized. So to create my 2A table, we did this in a previous lesson. We're talking about lateness and Regents results. So we're going to do late and then not late on one axis. And then we're going to talk about pass and not pass. And again, we don't want to get into like, well, if you're not passing or failing, there could be, maybe they didn't take it. We're just going to say yes and no for each. We're going to keep it very simple. I feel like I'm going to take up too much space here with this, but whatever. So, because there's percents in this particular problem, the total is 100. 32 arrived at school late. So my total for late is 32. 72% pass. 14% of the students who do not arrive late do not pass their Regents exams. So that's conditional. I'm only looking at the students who do not arrive late. So I can subtract these here. 14% of 68. So this is definitely a little twist in this question. 14% of the 68% do not pass their Regents exam. So that's going to be 0.14 times 68. We can pop that into the calculator. 0.14 times 68 is going to be 9.52. So 9.52 is going to go there. Again, it said that 14% of the students who do not arrive late, that's the 68%, 14% of them do not pass their Regents exams. So let's fill in the rest of this table so we can make sure we have all the information that we need. I can subtract 100 and the 72 for 28. I can subtract the 28 and the 9.52. Whoops, that was a little too much. 28 minus 9.52 is 18.48. I could subtract 72 and 18.48. And this doesn't make any sense, this problem. So we're not going to do this problem because it doesn't make any sense. Sorry, because this can't be more than this. So, I don't know. Something's not right. Let me see if I can find what's not right. Oh, wait. Hold on. I see what's not right. 68 minus 9. I don't know where I put 20. Oh, I see what I did. 28 minus 9.52 is, this is 18.48. And then 32 minus 18.48 is 13.52. And now it's making more sense. And 72 minus 13.52 is 58.48. And that makes more sense. So, now that I have that, let's get a different color. Student is late and student passes Regents exams. So let's have A, B, student is late. And let's have B, B passes Regents. It wants to know if they're independent. So, I don't know where I'm going to do this. P of A and B equals P of A times P of B. So, P of A and B, student is late and passes Regents, is 13.52 over 100. P of A, student is late, is 32 over 100. P of B, student passes the Regents, is 72 over 100. So my left-hand side, 13.52 over 100 is 0.1352. And then I got 32 over 100 times 72 over 100. I got 144 over 625. I don't think they're going to be the same, but I can double check by doing 144 divided by 625. That is not 0.1352. They are not equal, so it's not independent. You could have done the P of A equals P of A slash B. I'm not going to do that. I've done enough, using both. You really just need to do one of them. I'd want to do a few where I did both, so you saw that you can use both. Just be careful when you're creating your table. This one was definitely a little tricky with this sentence here. 14% of the students who do not arrive late do not pass the Regents exams. Again, to deal with that, you had to do 14% of the total that are not late. But that's a twist. I don't love that twist on this problem. I would probably want to take this problem out, maybe put it at the end of the lesson, just because it's a little trickier. All right, what else do I want to do with you? Let's take a look at number 9. And so basically for these ones I'm skipping here, if there's no two-way table, you're probably going to want to make a two-way table. 9. Sean's team has a baseball game. He pitches 50% of the games. There is a 40% chance of rain during the game tomorrow. If the probability that it rains given that Sean pitches is 40%, it can be concluded that these two events are. Well, let's take a look at what information they're giving us. So he pitches 50% of the games. So let's make A Sean pitches. And that makes P of A 50%. You can leave it as 50. You can make it into a decimal. It doesn't really matter for probability. I'll just make it into a decimal, so we're probably more comfortable doing that. There's a 40% chance of rain. So let's let B be it rains. If the probability that it rains given that Sean pitches. So the condition is that Sean pitches. The condition is A. So it's saying that the probability of B given A is 0.4. It can be concluded that, well, I don't have P of A and B equals P of A times P of B. I don't have enough information for that one. P of A equals P of A slash B. Now understand that A and P are like interchangeable. It doesn't matter which one's which. So I do have that. P of B equals P of B slash A means the same thing as P of A equals P of A slash B. They're equal. Therefore, they're independent. This right here is saying that P of B equals P of B slash A, which means the same thing as P of A equals P of A given B. It doesn't matter if it's A or B, but it matters that the first one must match that. So I don't have to create a two-way table for this example because it gave me that P of B equals P of B slash A. In other words, P of A equals P of A slash B. Fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D that a customer uses the drive-through and F are independent. So this is different. I'm telling you that they're independent. If they're independent, I know two things. I know that P of, instead of A and B, it's F and D. I know that P of F and D equals P of F times P of D. I also know that P of F equals P of F slash D. If it's telling me it's independent, I know those two things are true. So if it's P of F is 0.8, then P of F slash D must be the same as that. So it's 0.8. So that's a conceptual question. There's really not much to do. It's just to understand that if they're independent, that I know that these two things hold true. So P of F and P of F given D have to be the same. And remember, this letter and the first letter must match in order for that to hold true. That's basically it. All right, the most important stuff is the beginning. But, later on, that stuff obviously you need to be able to do as well. Just one thing I want to bring up that comes up in a couple of these questions. Mutually exclusive. Mutually exclusive means that P of A and B equals 0. It basically means that A and B have nothing to do with each other. There's no intersection between A and B. They've never asked a question in the Regents where mutually exclusive was an answer, but it has been a couple of choices. So that's basically what mutually exclusive means. So if I say what's the probability that someone is in 10th grade and someone is in 11th grade, those would be mutually exclusive because you can't be in both. If I said what's the probability that someone is in geometry and someone is in algebra 2, those are not mutually exclusive because you could have a student taking both at the same time. Mutually exclusive means there's no intersection of the two events. P of A and B equals 0. So just, want to mention that, but it's not really an important thing. So your classwork/homework is to finish this. This is a very, very, very commonly asked Regents topic. To determine if events are independent, you have two choices. You have P of A and B equals P of A times P of B, and P of A equals P of A slash B for independency.